Today's lesson is on properties of chords. You'll remember from our previous vocabulary that a chord is simply a segment that has endpoints on the circle. So that is a chord. So the first property we want to look at for our chords is if two chords are congruent, then the arcs that they cut off, so that would be this arc and this arc, those arcs that they cut off are congruent also. So this arc and this arc would have to have the same measure if these two chords were congruent to each other. That's an important property. Next step, this one, we've got a diameter, and we're going to say if the diameter is perpendicular to the chord. So diameter perpendicular to the chord. I'll write that down for you. Two things happen. It bisects the chord, and it bisects the arc. So if the diameter is perpendicular to the chord gets cut in half, and this arc down here gets cut in half. That's what happens if the diameter is perpendicular to a chord. Next step. If I have two chords, I'm going to make that the center. And I'm going to measure the distance from the center to the chord. Now, when I measure a distance, it's got to be perpendicular to the chord. So if I measure the distance from the center to the chord, let's say that one's 5. And then I measure the distance from the center to this chord, and it's also 5. Then these two chords are equal to each other. If the chords are the same distance from the center, then they're equal to each other. If the chords, I'm going to use the word equidistant because that means the same distance. If the chords are equidistant from the center, then they are congruent. Alrighty. Next step, we're going to take this shape, which is a wonky looking pentagon, but notice that every single vertex of the pentagon touches the circle. So we're going to say that this pentagon is inscribed in our circle. Pentagon is inscribed in the circle. So if a shape is inside a circle and every vertex touches the circle, it is inscribed because it's inside. Now, if we were talking about a circle, we're going to say the circle is circumscribed about the pentagon. So the shape that's on the outside is circumscribed. So for a circle to be circumscribed about a shape, it has to touch the shape of a vertex. Those are a couple of extra vocabulary words that we got. So now let's look at some of the practice problems we're going to do together, and then you can work on some homework and take your exit ticket. So this is on the page labeled Elaborate. So here we go. First off, M is the center, arc CDE is 220. So if CDE is 220 and DE is 120, I'm going to say that's 100. So we want to find the value of X. Well, what if we found arc FE? So let's add these up. 70 plus 120 plus 100 is what, 290? And if I subtract that from 360, I get 70. So arc EF is 70. Well, what do you know? Arc CF is 70. So remember that if two arcs are the same, what do we know about their two chords? X would have to be 9. Because if the chords are the same, then the arcs they cut off are congruent. So that's an important one to know. Let's go down to number 5. This one says M is the center and AB is 30. So AB is diameter. If the diameter is 30, then each radius is 15. That's good to know. And they want us to find, let's see, FE and angle EMF. All right, we'll trace that in a different color. Angle EMF. We'll find that angle next. All right, so here's what we're going to do. Remember that every radius in a circle is the same length. So I could draw a radius from M to D and know that it's also 15, just like this one was 15. And now I've got myself a right triangle. So I can say a squared plus 6 squared equals 15 squared, and get an answer for that one. Let's see. And I got the square root of 189. For my segment right here, this is approximately 13.748. That's an awful number, but that's what it is. And now how am I supposed to figure out this angle right here? I would guess some trigonometry would come in handy. So you could use, let's see, one thing to know, this is interesting tidbit, this angle over here and this angle right here have to be the same. Because remember, if I have to pretend like that's a diameter. If a diameter is perpendicular to the chord, it cuts the chord in half and it cuts this arc in half as well. So that means those central angles would be the same. So if I wanted to find the measure of angle EMF, I would have to use some trigonometry. So if I want this angle, I would use the cosine of x equals 6 over 15. So this is that one where you do the second cosine. Make sure you're in degrees. Make sure you're in degrees. Get that so you can see it. And I'm going to say second cosine of 6 over 15. And that angle is about 66 degrees. We'll just round off to the nearest degree. So that would be your answer for that one. That one was a little challenging. I don't know that you'll see a lot like that, but if you know how to do that one, you can handle most anything. Number 6. That's an interesting looking picture. Let's see what we can accomplish here. It says that segment OD is 6. And then segment AE is 3 root 3. When did we see things that had a square root of 3 in them? If you're thinking 30, 60, 90 triangles, you might be right. We're going to find the measure of angle COB. So this is what we want for our final answer. We'll see what that has to do with everything else. Well, let's see. If the radius is 6, you have to remember I can draw a radius anywhere I want to. So from O to B is a radius. It's also 6. Remember, if the diameter was perpendicular to the chord, it bisected the chord. So from E to B has to be 3 square root of 3. So you can either do the Pythagorean theorem, or if you recognize your pattern here, where we had x root 3, x, and 2x, that's the pattern for our 30, 60, 90 triangle. So that means that this angle right here is the 60 degrees. So remembering your special right triangles is always a good thing. You never know when they're going to pop up again. All right, on the back, I'm going to do number 7 and number 9. Number 7. It says M is the center, from C to E is 8, and they want you to find from A to B. So let's think about our properties of chords. Notice that segment CD is 4 units from the center, and segment AB is 4 units from the center. If you think back to our properties, that means that segment CD and segment AB are congruent to each other. We also know that because ME is perpendicular to CD, it bisects. So CD is a total of 16, and since AB is congruent, it is also 16. So that kind of put a couple of properties together. Now notice that I know ME is not a diameter, but because it's come from the center, we're going to treat it like a diameter, even though it's just a portion of the diameter. All right, number 9. Got a great big picture for this one. As the center, we're supposed to find the length of segment AB right here. Okay, this one looks a little bit complex. It's actually pretty easy. So we'll work through it. So I know that this piece right here is a 3. That was 16. Well, let's do this. Notice the radius is 20. I can draw the radius anywhere. I'm going to draw a radius from M to X and label it 20. So if this is 20 and this is 16, and that's a right angle, a little Pythagorean theorem is going to get me my answer for this little segment from M to right there. So I'm going to say the square root of 20 squared minus 16 squared gives me 12. So this little portion from here to here is 12. Not drawn scale, that shouldn't panic you because you're used to that. So the distance from M to C is a total of 15. That's going to come in handy. Now I'm going to draw another radius because I can draw a radius anywhere I want to from M to B. Well, guess how long the radius from M to B is? If you said 20, you are correct. So again, Pythagorean theorem, my hypotenuse is 20, one leg is 15, and I'm going to solve for CB and finish off my right triangle. So the square root of 20 squared minus 15 squared. Well, that didn't come out nice. Is 13.2287. Let's say it's the square root of 175, because that didn't come out nicely. The square root of 175. We can simplify that later. Now, if CB is the square root of 175, we should be able to calculate the length of AB, because remember, perpendicular to the chord bisects it. So from A to B is actually twice as much, 2 square root of 175. And we're going to simplify that because we like our answers in simplest radical form, if at all possible. I think 25 goes into that. A bunch of times, 7 times. So this gives me a 5 to take out of the square root. So our final answer, 10 root 7 for the length of segment AB. So if you can't give an answer in simplest radical form, we love that. Sometimes we do have to use decimals. So that's your lesson on properties of chords. If you have any questions, let us know. Good luck.